And welcome to the Daily Space Weather. Smasho here, coming at you from the Smash News Network, least busted name in news, just bringing you the most comprehensive space weather, meteorological information, and imagery of the sun that you'll find anywhere in the world. It's exciting stuff. Thanks to all of our new viewers who tuned in yesterday for the first time. Cheers. Congratulations on realizing the channel exists. We've got new sunspots rising in the east. We've got an M-class flare that just happened a few hours ago. And this is some additional imagery here from SDO. That's 171 plus 335 angstroms. You can see that M-class flare happening right at the end. Let's take a look at those rising sunspots. Two large sunspot groups there rising in the east. Let's take a look at another holistic view here. Here is the full disk view in SDO intensitygram. So we'll have an uptick today in the sunspot number. We did see this group in the south disappear and then reappear. So we'll have at least two more named sunspot groups. We'll show you some up-close and personal imagery of those and the magnetic fields later in the video. There's your colorized magnetogram from SDO. Once again, thanks everybody for tuning in and stargazing with us at the Smash News Network, least busted name in news. Take a moment to press like, subscribe, share, etc. if you haven't already done so. Once again, thanks to our new viewers. If you haven't seen our playlists, you can find playlists for all kinds of things besides space weather and meteorology segments like Do One Thing, Driving, Riding, and Pro Tips, Ownage, Food and Drink, Terms Defined, The Diamond Anvil, Too Hard to Smash, Cosmology segments, and more. So thanks to our YouTube subscribers for putting up with the pathetic censorship on the platform. Low the past 5+ years as we produce the most detailed space weather content that there is. We've also created our own subscription services site at smashomash.com/SmashTeam. Give Smash staff a raise by becoming a member at the Smash Team. Gold or silver will get you additional things, and we just put up just this morning a post that's only available to gold level Smash Team members. So thanks especially to our gold level Smash Team members. Credit crawl coming back to our patrons as well. Visit our links, etc. Thanks to everybody who has. Welcome to the Neo Renaissance. Smashomash.com is the homepage. We are in the process of composing a paper explaining the mechanism, the likely plausible mechanism behind the solar sunspot cycles and solar polar field reversal cycles. You can also find on our links, both below the video and on the homepage at smashomash.com, to our Hemp Lucid shop, our latest affiliate/sponsor. It's only the best, more popular than all the rest, is the water-soluble CBD tincture. Again, links below the video to that. They make great gifts. Get a 3-pack of lip balm if you're looking for something minor to buy your pals for Christmas. Next, free speech is not fixed by any stretch of the imagination. I keep seeing Elon's quotes and Elon Musk's quotes, and I don't care at all about any of that. Free speech not fixed whatsoever. However, we are on Twitter. So if you don't have an account over there, make an account over on Twitter. And I don't want to show you too much because I want you to go create an account on Twitter and follow us. Look at the pathetic number of followers, 337 followers, despite pushing 18,000 tweets and daily original content. Next, looking at volcanoes, and we're starting out with Mauna Loa. You see that hot spot there? That is hotter than the infrared satellite can detect. It's off the scale of hot. Also some hot spots at Kilauea there showing up. But the big story is, of course, Mauna Loa. So let's take a look at a diagram. That's the infrared satellite imagery, by the way, for the past few hours. And there is the way the lava flow is going. It's going to the north and to the northeast out of the main Mauna Loa summit crater. There is the path. So multiple fissures have opened, and we've got some flow fronts showing up there. Some of the lava flows are reaching some flat areas, but that is the way the current new lava flows have been operating. See what else is erupting here around the world. Shivaluch continues to erupt on the Kamchatka Peninsula and produce, massive block and ash flow took place on the 29th. Shivaluch producing a flight level 130. It's a 13,000-foot ash plume as Shivaluch explodes. Also, Ibu now back in the list, flight level 070, 7,000-foot ash plume, 14,000-foot ash plume over East Java from Semeru. And there is your updated information about Mauna Loa, the Earth's largest active volcano. Fissure 3's flow is expected to slow down here as it reaches a flat spot. That will cause lava to spread out and inflate, most likely. A common feature of flat spots and lava flows. And Popocatépetl exploding in central Mexico, flight level 190. 19,000-foot ash plume from Popocatépetl. Fuego in Guatemala, flight level 170 as Fuego explodes. Nevado de Ruiz exploding in Colombia. 19,000-foot ash plume. 20,000-foot ash plume from Sangay as Sangay explodes. Also in Ecuador is Revenador exploding. Flight level 170. Flight level 240 over Sabancaya. A stark reminder to not pole vault the caldera. If you're going on a volcanic vacation, leave the vault pole at home. Visit our merch for Do Not Pole Vault the Caldera merch links. Next, looking at seismicity here. So there's the past 90 days. Things have been pretty calm over the past 24 hours. Largest quake was a 5.7 in Iran. That likely caused some damage as we see some orange and yellow on the pager and shake maps. 5.7 at Iran near the Arabian Sea, it looks like. So yeah, no quakes of a 6 or larger magnitude. There was a mid-Atlantic ridge quake. Texas still shaking a little bit there. The western portion of Texas showing a recent uptick in seismic activity. Indonesia had a 5.2. The central Atlantic ridge had a 5.3. And let's get back to space, because plenty of stuff going on the closest star here. Now we've got the sunspot that was suspending the Eugene Bagashov filament up here in the northeast. This is our house favorite wavelength, 171 angstroms. And thanks for leaving a comment, Cookie Spacey. Delighted that Twitch actually sent you a notification. Twitch.tv/SmashOmash, by the way, is where we regularly stream live. The 10.7 centimeter radial flux has come up to 111 solar flux units. 111 is the new 10.7 centimeter radial flux number. And that number is a number of solar flux units. So solar flux units are 10,000 joules of radial flux density. Look at the sunspot number dipping off a cliff. Well, it's going to come back up promptly here, as we'll have a bunch of new sunspots. And 2 of those groups contain umbrae that are larger than planet Earth itself. Space Weather Enthusiast dashboard forecasting some additional geomagnetic unrest late in the day today. And it looks like we're expecting the coronal hole high-speed stream to subside. We've got some janky readings. Let's take a look at Earth's magnetic moment from space for the past 4 hours. So this is the last 4 hours of Earth's magnetic moment from space. It's showing magnetohydrodynamic pressure. And we have a bit of an inconsistent solar wind happening there. Some variations in the solar wind speed and density, which we'll show you here in a moment on the real-time solar wind data. Next, Earth's magnetic moment from the ground for the past 4 hours. This will show you the most likely places to see the aurora, also to see pipeline, rail line, and power grid induction. The units depicted here are nanotesla, which is magnetic flux density. It's the ground magnetic perturbations map for the past 4 hours. We show it daily on the channel. The data is not visible in archival format. Yet another reason to watch the most detailed space weather videos in the known universe. Next, moving to the KP index. It's a measurement of global geomagnetism. KP 3.67 is the current state of affairs. And as you can see, we did see brief periods of minor geomagnetic storm conditions over the past 24 hours, where we reached KP5. Next, the real-time solar wind. Again, it's very jittery here, seeing large variations in the temperature, the solar wind speed, solar wind density, also the magnetic field. So some significant variations happening here. The current situation is about 567 kilometers per second for the solar wind speed. Solar wind density just over 12 protons per cubic centimeter. We have seen a decrease in the magnetic field here in the top frame also. BZ looks like it is leaning toward positive BZ territory. Could it be a subsiding of the coronal hole wind stream? It certainly looks like it may be happening. Next, looking at magnetic data, this is the GOES magnetometer for the GOES 16 and GOES 17 for the past 3 days. Nothing to write home about there. Let's take a look at the heliospheric current sheet, as there is a South Pole current sheet speeding this way. So here you can see the South Pole current sheet depicted in red, North Pole current sheet depicted in green. There's the south. Here's the north. And by tomorrow, we may see a South Pole current sheet. That might give us some indication as to what's going to go on with those rising sunspot groups. I would tend to suspect that the one in the north might not be as significant as the one in the south. That may give us some insight, by the way, into how those sunspots will evolve. That top view ecliptic plane field plot data, if you know how to read it, if you've watched the channel for a long time, we'll be keeping an eye on that. That'll actually give us a forecast of what those sunspots will do. If we see the North Pole current sheet slowing down, that indicates the South Pole sunspot will be stronger, and vice versa if we see the South Pole current sheet winning out on that magnetic tug-of-war in the east. Next, our line of sight field plot. There's the solar B field in blue, north solar polar field in green, south in red. We've got some South Pole-oriented coronal holes rotating in here in the northeast. Let's take a look at those next. There you have that. That's our line of sight coronal hole plot. And the current coronal hole high-speed stream is provided by these North Pole-oriented coronal holes that are now rotating into the west. And as we forecasted a couple days ago, much better definition of the South Pole-oriented coronal hole here rotating in the east. So here we're seeing some upticks in solar activity both in sunspot and coronal holes. We're seeing higher speed coronal hole high-speed streams. We reached over 700 kilometers per second on this currently occurring one. And more trans-equatorial coronal holes means more activity, more aurorae, more exciting things happening in space weather. And let's move to sunspots next that we viewed the SDO 211 angstroms wavelength. Fantastic imagery there of coronal holes from SDO. So here's a sunspot report. We'll have a new sunspot named down here. We'll also have 2 more named sunspot groups over here in the east. So this will be 3153, this will be 3154, and 3155. And the likelihood of solar flares does go up as we've got large sunspots right on the limb, the most likely place for large sunspots to occur. So let's take a look at sunspots here. We've added 193 angstroms to show the extended corona here. So that's the solar magnetogram from SDO plus the extended corona, 193 angstroms. Here's the SDO continuum with the same 193 wavelengths. And let's take a look a little bit closer here. Here's the southern hemisphere. Sunspot 3153 down there in the south. I see a little bit of growth happening there in the past 24 at sunspot 3153. Also, you see the rising at Sunspot 3154 over here. Don't miss that one. Looks like it might be beta gamma class already. We'll be looking at that here in a moment. Next, the Northern Hemisphere. We've added 193 angstroms back in. There is an M-class flare right at the end. Right there, you can see that M-class flare kicking off. And here is just the SDO continuum. Sunspot 3155 is right over here. Believe it or not, it is there. We'll show you close-ups of that a little bit later. Next, energetic particles. No relativistic particles showing up here, despite that M-class flare. It was a small M-class flare, but the largest flare we've had in quite some time here. It was an M1.1, and it was of moderate duration there. Not a sudden impulse, but a medium length flare. So that's 94 angstroms. Let's add 131 angstroms to add a little bit of extra flavor. All these videos are the past 24 hours. And let's subtract 94 angstroms to just show 131 by itself. So that flaring activity all in the northwestern limb. Don't be surprised to see large flares coming out of the eastern limb, as we've got large spots just rising. And, of course, we always encourage our viewers to look up. So if you want to know what's going on above your head, try in-the-sky.org. We've got the galaxy just setting here at the moment. You can see this blue area here. That's the galactic plane. Cygnus just rose about an hour and a half ago. That's what's going on over our heads in Lehigh Valley, Pennsylvania. You've got Mercury and Venus rising after the sun, making those into evening stars, or evening planets, I should say. Here's your solar system forecast. And welcome to Smashcember, by the way. Smashcember. We'll be doing this, the 12 days of Smashmas, by releasing original music 12 days in a row. More on that later today. First, your solar system forecast. Keep in mind it is not to scale. There's where things will be in a week. It looks like the full moon will fall on the 8th of December. And let's take a look at some coronagraphs. So here's the George Mason University coronagraphs from yesterday. We do have some CMEs, and you may be wondering if those are directed toward your doorstep. And we don't blame you. We've been wondering the same thing, and we'll get to it here in just a moment. So that's yesterday's imagery from George Mason. Might be a little bit inconclusive in terms of where those CMEs are headed. Here's today's 39 frames so far. And let's take a look at it from stereo A to give us a little bit more perspective here from Lagrange point 5. The location of stereo A will also show Lagrange 1, the location of Soho-Lascaux C3. So we paused this here because the only CME that's even anywhere near Earth in terms of being on the Earth side is this one happening this morning about 9 o'clock Universal Time. And that is definitely not earthly directed. Earth would be off on this line. This CME is headed way off to the northwest, actually. If you check it out here on Soho-Lascaux C3, you can see it's coming out of the northwest. No earthly directed CMEs are currently on tap. And let's do some custom videos here. This is the last 24 in composite, 304 angstroms from SDO, as well as Soho-Lascaux C2 in red, C3 in blue. Let's zoom out to the full zoom. There you go. And it's time to move on to look at filaments. So here's the current situation from El Teide, Spain's ground-based solar observatory. And we've got massive filaments here on the Earth-facing side of the solar disk. Additional coronal mass ejections remain at nearly 100% likelihood. Huge filament down here. Huge filament here. Also, the Eugene Bagashov filament now finally rising ahead of Sunspot 3155. There it is. It's the Eugene Bagashov filament. Let us know in the comments if you think it's going to destroy all civilization. Somehow, I doubt it. But that is the ground-based solar observatory at El Teide, Spain. Huge number of filaments. Likelihood of solar flares goes way up. Likelihood of coronal mass ejections, again, nearly at 100%. Here's the last 24 from SDO. The spectacular high-resolution, low field of view imagery from SDO there, and 304 angstroms ionized helium. One of the enduring favorites. Let's take a look at some more recent data here. Just the past about 2.5 hours from the GOES 16 SUVI. Always a classic. It's good enough that we stream it all day long on the regs. On the Twitch channel, twitch.tv/smashomash. And it looks like there's a little bit of plasma instability happening here just ahead of the Eugene Bagashov filament. That might be an area to watch. Perhaps the Eugene Bagashov filament becoming a little bit unstable here at the moment. It's time to move into bonus features. So the satellite's community dashboard here showing some charging hazards over the Central Pacific Ocean. That surface charging caused by low energy electrons building up on the outsides of satellites. Here is the GOES electron flux as measured from the GOES 16 and 17 from their geosynchronous near equatorial orbits. They use radiography and they make the measurement at the F layer of the ionosphere, which is at about 300 kilometers of altitude. We're expecting some very high levels of electron flux, so it's an electron storm coming. It could cause some satellite issues in the coming days. You can see the forecast there from NOAA forecasting very, very high levels of electron flux. And I would tend to agree as we had a very, very high-speed coronal hole high-speed stream. There's the one-year chart to put it in context, and NOAA forecasting literally up here at this mark, forecasting the highest levels of electron flux we've seen in a year, which is what's depicted on that imagery. Next, we'll take a look at the F ionosphere layer, the vibrational frequency therein. It's the bridge between Earth and space. It's at about 300 kilometers of altitude. Feel free to pause the video on this frame if you're not familiar with things like electromagnetic radiation penetration, thermospheric temperatures, and atmospheric concentrations of molecules. So here is the F layer. We're going to show the anomalygram and the raw vibrational frequency. So that is the previous day in vibrational frequency. Here's the previous day in anomalygram. That's anomaly in megahertz from a 30-day median. And lots of low-frequency anomalies here going on. Some mid-Atlantic oddities happening as well. Look in this area right here. You'll see a rapid swing from high to low-frequency anomaly there. And let's pull the latest image. There's 1330 universal time ionogram, 1330 universal time anomalygram. And let's continue on to show the total electron content forecast. It's the free electrons between the inner portion of the outer Van Allen belt and your GPS handset. Your GPS satellite's located at about 12,500 miles of altitude. There's the total electron content map. And here's the animation. Thank goodness this one's back. This is a splentacular space weather sequence here. The total electron content. Once again, that's about 12,500 miles of altitude down to your handset. It's literally a count of the free electrons. Those cause signal refraction. And of course, GPS errors are most likely around the equator at noon if you were not aware. That's what's going on in the total electron content. And let's take a look at these sunspots. Again, we've got two new large ones. So first, let's take a look at the existing ones. Here we've got 3152. Still beta gamma class. Down here we've got 3153. Still beta gamma class. Here's 1354, and it's beta gamma class. So yes, likelihood of solar flares way up as a result of that, especially. That is a magnetically complex sunspot group. It could even be beta gamma delta class, but it's certainly beta gamma class. Let's check this group right here. There's a second sunspot group or two forming ahead of it. So we're going to have a huge uptick here in the sunspot number, like I said. Another sunspot there the size of the Earth about. And some umbrae ahead of it there, just behind the Eugene Bagashov filament. So that's what's going on. How about one more series of images? This is yesterday plus today from SDO. That is Iron Star, 335, 193 plus 94 angstroms. 3 different species of ionized iron showing some great variation there. The lively star of our local neighborhood. Next, it's time to get into the realm of meteorology. So we'll start things out by looking at some cherry-picked information. Before we do that, let's take a look at some merch. So if you're not familiar with the merch items, click the links below the video. You'll find our merch in order of best selling. And it does indeed feature some products here that will not be named because the video is designed for YouTube. Today's featured product is Mensa, Make Earth Not Suck Again. Because it's up to you, not giant heaving bureaucracies that are unable to get out of their own way or do their own jobs effectively. Mensa, Make Earth Not Suck Again. It's up to you. It's got our website on there as well. And of course, I'm wearing the merch because I'm not only Smash-O-Mash, but I'm also a client. So Make Earth Not Suck Again. Here are the products that you can obtain. And these are being worn all around the world, actually. We've got some Mensa products all the way down in Tasmania. And for our international viewers, most of the planet allows you to obtain our merch. You can find links on the homepage, Smash-O Merch at smashomash.com. You'll find a link there as well as below the video in the description. Thanks to everybody who supported the channel that way. Give Smash staff a raise or give your friends a kick in the you-know-what, since it's up to them also to make Earth not suck again. Next, it's some cherry-picked data. Oh my God, look at how hot the Pacific Ocean is. Look at this, folks. Just look at this. Are you spooked? That right there is 6 degrees Fahrenheit above normal. Stop the presses and tell CNN that this portion of the Pacific Ocean is 6 degrees Fahrenheit above normal, which means Greta Thunberg is going to evaporate at any moment. Plants will get greener. And Obama's doorstep will be underwater in a matter of minutes. So look at that section. Oh my God, it's sea surface temperature anomaly. Look how hot it is there. And please just ignore that all of that blue. That's nothing to see here, folks. Nothing to see here. Look at that hot water in the central Pacific. Oh my God, the equatorial Pacific is burning up. It's evaporating. It's got to be the cause. It's certainly, oh my God. Dear God, geez, oh whiz. Anyway, let's take a look at sea surface temperatures around the world. Oh my God, it's very hot over here also. It's 7 degrees Fahrenheit above normal in that area. We'll ignore this area completely because nobody's spooked about cold water, only hot water because reasons. Anyway, there's the north. There's the full Pacific Ocean view. There's the Indian Ocean. There's the Atlantic Ocean. We've also got currents depicted here, by the way, if you're wondering what's going on in the North Atlantic. There's a bunch of mixtures happening, actually. The water anomalously warm around the east coast of the U.S. and anomalously cold in the North Atlantic. Some very cold water right there. 17.9 degrees Fahrenheit below normal. And over here, 13.2 degrees above normal. So some major mixing happening there, some vertical mixing undoubtedly occurring. Keep in mind, folks, sea surface temperature doesn't really give you an accurate indication of Earth's climate. It's only showing you the top 3 meters of water, hence the term surface. And let's take a look at winds. So here are the surface winds of the eastern world. Here are the jet streams of the eastern world. And if you only used one item to forecast global weather patterns, the jet stream would be the one to use, the 250 hectopascal winds. Here are the 250 hectopascal winds known as the jet stream over the western world, the U.S., doubled up powerful jet stream here over the U.S. And we're getting windy conditions here in Pennsylvania. That is eastern Pennsylvania. We're located in Lehigh Valley, about an hour from New York and Philadelphia. There are the surface wind scenarios. A strong onshore wind there blowing in between Nova Scotia and Newfoundland. Here are the surface winds of the central world. That's Africa, Europe, and the Middle East. And here are the jet streams of the central world. We've got some forecasts as we do most days. Here is your sunrise over the western portion of the planet. That's the NASA GOES Interactive Visible Satellite. Some great shadows being casted by those cloud tops there and so on. And let's continue on to our weather.gov map. So lots of winter storm warnings and winter weather advisories in the northwestern portion of the state. Also some strong winds on Lake Huron and Lake Michigan. Here is your key. We'll scroll down so you can see the color coding there for a minute. If your county's lit, click your county on weather.gov. We can't go over all that. It's a little bit too much information. We're going from space to Earth and not too much lower than that. So here's your GFS forecast for the next 72 hours. And over 4 feet of snow forecasted for portions of California here. You can see that turning white. That is the 48-inch line. That's 4 feet of additional snow there forecasted for portions of California. That's a 72-hour GFS accumulated positive snow depth change forecast in inches. And we'll also show you the pressure and precipitation forecast based on the same model, the GFS, for the same period, 72 hours. So a double snow whammy to hit California there. 2 heavy snows in a row. The second one wetter than the first. But heavy, heavy snow there in the eastern portion of California. Also the northern Rockies getting a significant spattering of snow there. Once again, there's your snow forecast for the next 72 hours. And there's your pressure and precipitation forecast for the next 72 hours. Let's take a brief look at snow depth here based on the Euro model. Here's where things will be on Sunday at 10 a.m. Eastern Time. And what does the Euro model have for snow depth in California here? Making it very far south. 45 inches, 51 inches there forecasted for portions of California. So heavy snow's coming to certain portions of the state. Let's take a look at lightning next. The NASA GOES lightning mapper, a powerful, large area of lightning here in the central Atlantic. And here's a real-time lightning map. We like to show our viewers where the teeth of the storms are, so lightningmaps.org helps with that, providing real-time lightning maps powered by blitzachtung.org. It's always a delight. We do have some active cells in the Gulf. Also some European lightning kicking off. Continuing on to our U.S. Doppler radar map. Give that a minute to draw up. We've got to refresh some other information as well, so just bear with me while we bring in the last segment of the video. The U.S. Doppler radar map, the water vapor map, and the shortwave radiation showing clouds and fog over the U.S. Don't forget to leave us a comment, whether it's nice or derogatory. It's not going to hurt my feelings. I've been getting in trouble on social media since before the word social media existed, as I was a game server admin and game message board admin and clan server admin and so forth for a long time, long before the Smash News Network was ever conceived. So here is the full 50-state view here of AUSA, the allegedly United States of America. And we will focus on the lower 48. Here's clouds and fog. It's still dark over about half of the country. So clouds and fog there, 3.9 nanometer radiation interactive weather satellite. And there is the water vapor map. Quite a bit of moisture over the northwestern portion of the U.S. You can see some activity happening here around the Rockies there as pressure changes massively, as air is forced over the Rocky Mountains, creating a pressure drop on the leeward side and a pressure increase on the windward side, as one would expect as the atmosphere attempts to reach static equilibrium. Here's your recap to close things out. U.S. Doppler radar. Shortwave radiation showing clouds and fog. Lots of low clouds over the Gulf of Mexico and the eastern Atlantic. I should say the western Atlantic. This portion right here, low clouds. We see low clouds, low clouds. And the water vapor should clear things up. If your Doppler is not being clear, the water vapor should help with that, especially if you realize that that dry air is more massive than the moist air, and cold air is more massive than warm air. Why do you think hot air balloons float? Hopefully that helps. Hopefully you've pressed like, subscribe, share, etc., told your friends and foes about the channel, and accepted our thanks for tuning in. Once again, congratulations on realizing the channel exists. I've been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back. Opinions expressed in this video, not necessarily the opinions of Smash News Network, least busted name in news.